Hello everyone, welcome to the series of Daily Quant Dose, where we are discussing some very important advanced level questions which are very unique from individual topics. So here's the next episode where we are going to cover a question of algebra. Keep this in mind, in Daily Quant Dose, you will be having those questions which are unique and in terms of level of difficulty, slightly on a higher side. And these are the questions where the concept is difficult to strike. And this is a type of question which is based on the concept which has been used in the previous year questions many times of CAT. Now let's look at this question, guys. This question is from the topic of algebra. Now let's have a look at it. It says that for what in largest integer the value of this is also an integer, guys, right? Now you can see that this is an expression and it's an algebraic expression, or you can say fractional algebraic expression where we want this number to be an integer. Now keep this in mind, this whole expression will result into an integer if the value in the denominator is going to be the factor of the value in the numerator, right? So this is the first step that should strike you, that this resultant expression will result into an integral value if this whole thing in the denominator is going to be the factor of this. Now, every time you came across a concept like this, where a fractional expression is given to you and the resultant should be an integer, this is the first line of thought that should strike you, right? Now, if I want this to be a factor of this, how would I get to know? This is a cubic equation, this is a quadratic equation, we'll have to factorize it, right? Now, the first thing that you need to know to solve the question is, what are the factors of this cubic equation? What are the factors of this cubic equation? For that, we need to use a hidden trial method. Here, f of n is given to you as n cube minus 12n plus 65. Now, if I put the value of n as 1, and how do you find the roots of a cubic equation? The first step is using the hidden trial method. Try putting the value of 1, 2, 3, 4, minus 1, minus 2, minus 3, which can be the root of this equation. One of these values must be the root of it. Otherwise, we'll never be able to factorize it. Now, if I put n as 1, this will be 1 minus 12 plus 65. Now, you see that the difference between positive value and the negative value is quite high. We want to reduce it. So we would be increasing the value of n at this moment. If I put n as 3, this would be 27 minus 36 plus 65. This is again, the difference is quite high. So we need to go further to the value of 5, right? We can also put it for 4. Now when I put it n as 5, this will be 125 minus 60 plus 65. Now again, the positive quantities are increasing. So let's shift ourselves to the negative side. And one thing that can strike you here is the summation of these two values. The summation of the magnitude of these two is same as this. That means if I replace n as minus 5, I will be able to find out the first root of this equation. You can see that this cubic equation is at 0 when you put the value of n as minus 5. That means n is equal to minus 5 is the root of this equation. Now, if this is the root of this equation, that means using the factor theorem, you can say that n plus 5 is going to be the factor of this equation. Now, that's the first step that you should be able to do to answer this question. Now, when I say n plus 5 is a factor of this cubic equation, then you need to divide it by n plus 5, right? Now, when you divide it by n plus 5, right, we need to do the division to know what is another quadratic equation that will be the factor of this cubic equation. So here the first coefficient would be n cube plus 5n square. Minus this get cancelled, right? So this finally will become minus 5n square minus 12n plus 65. Now if I further multiply it by minus 5, this will be minus 5n square minus 25n, right? This get cancelled. 13n plus 65. Now if I divide it by 13, this will become 13n plus 65 and this becomes 0. So now you see that this cubic equation in the numerator can be written as n plus 5 multiplied by n square minus 5n plus 13. And the value in the denominator is a quadratic equation. You guys can also factorize it, right? If I say n square plus n minus 20, you see that this can be written as plus 5n minus 4n. We need to break n in two parts where the product should be minus 20 and the summation should be n. So 5n minus 4n minus 20. I hope you know how to factorize a quadratic equation, right? Now this you can see can be written as n minus 4 into n plus 5. Now the value in the denominator is n minus 4 into n plus 5. Now this will get factorized, this will get cancelled. Finally, the resultant value that we will be left with will be n square minus 5n plus 13 divided by n minus 4. I see that. This cannot be further factorized because n squared minus 5n plus 13, the discriminant of this is less than 0. You can see that n squared minus 5n plus 13 का जो discriminant होगा वो less than 0 है. So therefore it cannot be factorized. इसके roots real नहीं होंगे. b square minus 4ac 5 का square 25 minus 4 into 13. 25 minus 52 will be negative. Now I want this to be an fractional value. Now, what should be the next step after this? What you need to do is you need to further break it down in terms of n minus 4. Because the thing is, we want this number to be the factorization of this factor of this number for highest possible value of n, right? Because we have to maximize the value of n, right? N का value सबसे ज़्यादा maximize करना है आपको. So what we need to do? Write it down in terms of n. This is n square, right? Minus 5n can be written as minus 4n minus n plus 13. Now, I'm not factorizing it, okay? I'm just trying to write down the value in the numerator in terms of n minus 4. Now, if I take n as common, this is n minus 4 minus n minus 13 divided by n minus 4. Now, if I divide it individually, this fraction will further be reduced to n minus 4 and n minus 4 will get cancelled. Minus n minus 13 upon n minus 4. So this whole expression is now reduced to this expression. Now you need to apply this concept. If I want n to be an integer value, here it will be an integer. I want this whole expression to be integer. That means this fractional should also be an integer. Now if I want this fraction to be integer, but I want the largest value of n, largest integer n for which the value of this is also an integer. So we want n to be the largest possible value, right? n की value को अगर मुझे largest बनाना है बच्चों, right? Here the number, the letter n has been missed. For what largest integer n? The value of this is also an integer. This is the question, guys, right? Now see that this value in the numerator is n minus 13, right? If I want to maximize the value of n, guys, you see that the maximum possible value of n you can take is 13. Why? Because if I take n as 13, the whole value in the numerator will become 0, and whatever value it become in the denominator, 0 upon anything is 0. So this whole expression will result in an integer. Now why I'm taking the highest possible value of n? Because the question says so, right? So therefore, the highest value of n that you can take here in the numerator will be 13. If I put n as 13 से ज्यादा इंक्रीज करोगे ना, तो आप देखो n minus 4 का जो वैल्यू होगा वो n minus 13 से हमेशा बड़ा होगा. Can I say this? If I take any value of n, now in the denominator you are subtracting 4, but in the numerator you are subtracting 13. So denominator में जो वैल्यू आएगा वो numerator से हमेशा बड़ा होगा. तो denominator अगर numerator से बड़ा है तो उसका फैक्टर कभी नहीं बन सकता है. So there is only one case. If I want the value in the denominator which is more than the value in the numerator to be the factor of this number, you take n in such a way so that the numerator becomes 0. So numerator अगर 0 बनेगा उसमें largest possible value जो n की हो सकती है 13. अब 13 पुट करोगे तो 0 upon 9, finally the largest value of this expression will become 13, and the largest value of n for which this is also an integer will be 13. Hence the answer to the question 13, guys. I hope you were able to learn the multiple concepts through this one single question. This is a lovely, amazing question. Everybody must practice question like this before CAT exam, because इसमें एक ही questions में आपको बहुत सारे concepts, right? Now let's have a look at it. On Unacademy, there is All India mock test going to happen on 20th November, right? This is the next mock test. This is today, right? This will be happening today, right? Last test of CAT. You guys can check yourself where do you stand among the number of students, and here The batch highlights, any batch that you join on Unacademy, you will be getting structured courses, unlimited access to live and recorded sessions, 25,000 plus practice questions, in-class doubt solving and performance evaluation through 100 plus mock tests, mentorship from CAT experts and IM graduates. These are the benefits. If you want to go for plus subscription or iconic subscription on Unacademy, you guys can use my code SME.YT. This will give you the maximum discount on plus. Plus, you will be able to avail my one-to-one mentorship and counseling for your exam preparation right till the time of your CAT exam preparation. And these are the benefits of Unacademy CAT subscription, guys, right? If you join any plus subscription, you will be getting digital notes, unlimited access, interactive live session, and structured courses and PDF. And these are the other benefits. For Iconic, you'll be getting digital as well as physical notes, GDP VAT, one-to-one live mentorship, live doubt solving. So use the code SME.YT for any subscription on Unacademy, whether it's a plus or it's an Iconic. Thank you so much for joining the session. See you in the next class. Thank you.